Assalamualaikum. I'm Shayan, and today I'm going to explain all these examples that we have been given in the assignment. So first of all, we have 7.1. Here is the Proteus circuit using Atmega 328P and a simple circuit with an LED attached to it. We have this code in which we have configured DDR-BS output, and then we used for loop to run it run the iterations till up to 55 to 55. Basically this code will count from 0 to 255. Let's see how it works in the Proteus. So here we go. This switching speed is too fast. Let's try to add some delay into it. Yeah, 100 ms. Let's see if it works. Yeah, it's not working. Anyways, if we add delay to it, then it will definitely get slower, and you can see that the counting will be a lot slower. It's counting from 1 to 0 to 255 to 56 bits in total. That's pretty much what this program is doing. On to the one next program, example 7.2. In this program we have an array of numbers, and you can say string. We have an array of string which is going to be printed from 0 to 10 in port B. Basically it will be printed as first 0 and 1 2 3 4 5 6 A B D C D, not 6. They will be printed on port B. We have a loop here which will ensure that all these 10 and 11 entries, actually not 10 entries, all these 10 entries are printed. So let's see how it works. Yeah, 0 0 1 0 0 0 1. So yeah, all those from 0 to what was it? A B C D D, I guess. All those will be printed here. So yeah, that's pretty much it. Go on to the next program. This is example 7.3, and no, actually this is 7.2. Let me write 7.3 here. Yeah, so here we have 7.3, example 7.3. In this we have DDR-B configured as output, as you can see here. Inside characters. So in this program we are toggling port B from 0 to 200. So it is toggling, we are toggling this 200 times from 0 to 199. Let's run this program and see what happens. The bits will get toggled most probably. Yeah, here you can see at 12 we have off 0, at 13 we have 1, then 14 0, 15 1, 16 0, 17 1, 7 0 and 8 1. So yeah, this program is toggling all those bits at port B. So next up we have 7.9, example 7.9. In this example, basically the port B will be displayed from 0, and output will be displayed on port B from 0 to F, which is basically 1 1 1 1 1 1 1, like 8 ones in binary and 255 in decimal. If we convert it in decimal, it will be 255. Basically what this program is doing is it will count from 0 to 255. Let's run this program and see what happens. Yeah, so as you can see here, this program actually there is no delay, so it's running at a very fast rate, but it's going from 0 to 255. Maybe we can see it. We'll pause it from here and then back into no. Yeah, we can see here basically it is counting from 0 to 255, which is FF and the hex. Yeah, that's pretty much it. So on to the next program, which is 7.1, example 7.11. Here we have two ports configured as output. First, area B, port B. The second one is port D. So basically what this program is doing is that we have used a loop here, if not while loop, and in while loop we used a condition, if else statement. So if the value is less than 100, it will be displayed at port B. That means output will be at port B. And if it's more than 100, greater than 100, then the output will be displayed at port D. Let's see. So yeah, as we can see here, the output is at port 17 and 7. So that means this program is working correctly. Next program, which is 7-12, example 7-12. In this example, we have configured three ports, area B, port B, port C, and port D. We have configured all three of them as output. Then we have applied AND operation at port B, OR operation at port C, and inverting operation at port D. Now it is called inverting operation. That's XOR and at port B or at port C, and XOR exclusive OR at port D, and we have inverting at port B again. So yeah, there's nothing much to show on this program in simulation. We can pretty much understand this program just from looking at the source code. Yeah, that's it. The next example is 7-17. In this example, we have here declared port D as an output port. Then we have while loop here, and in this you can see that only last two bits of port B. Here we have the variable, and we have stored pin B in that variable Z, and here we can see that only last two pins are 1 because we are using only last two pins. So this will make sure that only last two bit of data is saved. We don't need the rest of it. Depending on that, depending on the we are taking input from the user. So depending on the input, we have generated 4 cases here, and in all those cases we will issue a different ASCII character to the output. We have been given a table in the book, an example, the question of this example.